Hello and welcome everyone. Anna, can you hear me okay?
Hello everyone. Hello, Riley. Yes, I can hear you.
Thanks, Anna. Appreciate it. Welcome everyone. Thanks for joining today's live technical topic webinar. I hope you are all well. My name is Riley and I assist in coordinating our various free webinars we hold every month at EIT. You can find all of our upcoming and past webinars on the events page on our website. I'd just like to run over one thing before we get started, and that's disabling the sound and pop-up notifications. If you're not familiar with the webinar platform, it can be a little bit intrusive while you're trying to watch, so it is best to disable it beforehand. So you'll just need to go to your settings, which is in the bottom right-hand corner of your screen, or if you're on a mobile device, it might be in the session menu. And once you're in your settings, you will need to go to notification settings and untick all the boxes, and that will disable any sound or pop-up notifications you may get while you're in the webinar. So I hope that helps if anyone's having issues with that. So today's session will be discussing recent trends in evaluation and monitoring of existing concrete structures. So that was our technical topic webinar for today. And our presenter is Dr. Anna Evangelista, who is our EIT Civil and Structural Engineering course coordinator. She's a lecturer at EIT and she's also the Work Integrated Learning coordinator. So I'd just like to say we'd like to keep these webinars as interactive as possible, so please use the chat box if you have any questions or thoughts you'd like to share during this session. I'll be active in the chat box for most of the webinar, so I can answer any non-academic questions for you. And I'd just like to go over a couple of common questions that we get through these webinars, and that's regarding the copy of the slides and the video recording. Everyone registered for this webinar will receive a copy of these slides and a link to the video recording within the next 2 business days via email. So just check your junk email folder if you're looking out for that. And your certificate of attendance can also be provided to attendees who request one at the end of the session. So I'll be providing a link which will take you to a short online form or survey in which you need to complete in order to receive your certificate. And the certificates will be sent within 4 business days after the webinar. And if we have some time at the end, we will hold a quick Q&A session where you can ask any questions in the chat box, in which Anna or I will try to answer for you while we're live. So that's about it from me. I'll now hand over to Dr. Anna Evangelista, who is our civil instructor lecturer at EIT. So thank you, Anna. Take it away. Thank you.
Thank you, Riley, for the introduction. So first of all, hello everyone, welcome. I'm Anna. I'm a civil engineer. I'm a lecturer at EIT, and during my PhD, I worked with non-destructive tests. And that's the main idea to share with you today. This is the main motivation in relation to this topic, to share some personal information with you. This is all about sharing the ideas when you work as engineers, architects, or construction professionals. So the main agenda for today, just have a look here. We're going to start with some structural degradation. We'll be covering structural degradation. Then we're going to go through some non-destructive methods and some statistical consideration. And we will be also talking about structural health monitoring and some conclusions, final considerations at the end. So I'd like to start with this session. Hopefully you all are doing well and safe. This is the most important part in our lives today. And let's start with the causes of structural degradation. So as you can see here, what the main idea in relation to causes and structural degradation, I truly believe from early childhood, one of us will have experienced structural deterioration. Normally, depending on the materials limitations, design, construction practice, or some severe exposure, depends on the environment our structural element is exposed. So these type of deteriorations will cause some problems in relation to not only structural problems, but also aesthetic problems, right? And when we have a look into the broad topic of causes of degradation, normally I like to just divide in three main groups, as you can see. Progressive degradation, what it means from a broad perspective. It's this type of degradation we can assume that is the result of this degradation. You just remove the structure, the condition, the original condition in terms of resistance and capacity, right? So progressively, gracefully degradation will result into the mitigation and reduction in terms of the structural capacity. And sometimes we have combination, right, in terms of progressive and shock-based degradation. The shock, what shock means for us as structural engineers, when you have these events and these events just change their physical properties in a small period of time. So what we have in the reality, in real life situations, it's majority of the time we have the combination, right? Progressive plus shock-based degradation. So just trying to summarize, the causes we know, our infrastructure in terms of the lifetime can be reduced over time. And this is the points we need to consider when we just try to understand a bit more in terms of structural degradation. Progressive or caused by shocks, or pretty much combining these two situations is the most common one. So in a sequence into this point, I'd like to share some situations in real life. I'm not sure if you have faced these changes into the material geometric properties or affecting the performance. As you can see here, can we imagine the vertical alignment of this column? This is a bridge. And another type of degradation that we normally it calls our attention a lot is in relation to cracks. And when you talk about cracks, it's an entire world of information, right? We have cracks depends on the normally plastic shrinkage, freezing and thawing cycles. Depending on your country, we can have so different possibilities in terms of causes for cracking, right? In concrete, we can also assume problems in relation to inappropriate design and also construction practice. That's why I truly believe in more and more, this is the main objective of this session, is to open our minds that we need to work collaboratively. Engineers, architects, and construction professionals, right? It's not only about structural analysis and design, it's not only about project management. When you think about deterioration, when you think about decreasing in lifespan of infrastructure, we need to work together. This is the main point. And definitely the prediction of structural deterioration can can be very helpful to optimize the design of these infrastructure systems for over the entire life cycle. It's one point. And also just it's important to highlight one of the main problems when you work with reinforced concrete. I truly believe it's a common sense that there are many problems related to the corrosion process. So we'll be covering part of the analysis that can be done. And one point that we can start considering is more about the next slide. As structural engineers, architects, construction professionals, we need to have this in mind, right? Structural degradation and expected service life. It's related to our codes, it's related to our standards. But what we can see, in terms of structural degradations, we have these sides. Causes, as you could see before, improper concrete practicing, extreme weather conditions, natural disasters, sometimes we cannot avoid, right? But some of them we can simulate, some of them we can predict. Water leakage leading to corrosion. Sometimes a simple drainage project can be a solution to enhance surface life of pavements or any type of structural element. So on the other side, in terms of service life, our code, I'm just gonna highlight here the Australian code covering structural design. The aim of the design when you follow the code is just to produce a safe, this is number one, durable, serviceable. We need to think about aesthetics, economical, and sustainable structures, but we need to think about the service life, right? We cannot only consider in our projects a short period of time. Can you imagine infrastructure projects, the amount of investment, it's huge. So in our code, we have some guidance to follow. Here in Australia, Australian standard for the reinforced and pre-stressed concrete, we have the design life of 50 years, okay, around this. Also, the other point that we can start considering is in terms of the modeling, right? Deterioration modeling. There is so many resources available at the literature guiding us in terms of how we can predict, we can provide some modeling to predict the decrease in terms of physical conditions, right? And this is called deterioration modeling, when you can just provide some modeling and to predict predictive models in terms of the physical condition state of infrastructures or any type of, you can use this definition to not only for any type of structural element. And here we have this typical asset deterioration curve, no maintenance, definitely maintenance should be, it is a very important point to consider, but we normally have this relationship condition performance or against age, just to give us some ideas in terms of the parameters we need to include. When you work with deterioration modeling, we can consider the asset age, environmental conditions, construction methodology, materials type. All these parameters can be included in our model. So in relation to these models, it's a predictive model, right? So we can have nowadays different alternatives available at the literature. If you go and just try to search more in relation to this topic, we have deterministic models when we can work with regression models, or we can work with stochastic models using some simulations, Markovian, and more artificial intelligence models when you can work with, for example, artificial neural network. And I'm just gonna briefly give you some example in terms of an artificial neural network application in bridges. As you can see, it's just an example when types of factors that you can include when you work with artificial intelligence, in this case, artificial neural network. In a bridge, in a road network, in terms of inputs, you must consider the number of vehicles, the number of the population growth, climate. So this is more for the machine learners and learning researchers and data analysis. They can work with, they can train and provide some predictive model, right? So this is just to give an idea about what is available into the literature under this topic that we are sharing here, deterioration modeling. So several alternatives. So it depends on how we're gonna work with this in your workplace, for example. And I will be discussing some ideas in relation to how we can plan and conduct the step number one when you need to evaluate a concrete structure is in relate to in situ inspection, right? Visual inspection is the step number one when you can start familiarize yourselves and mapping all the situation, if it's a bridge, if it's a pavement, it's a building. Historically, we have in place strength tests conducted when you have the core drilled from the structures, and you can combine this type of test with some non-destructive tests. Later on, you can see this, but in-place tests normally can permit more economical evaluation of the concrete structure. But the critical aspect in this case is at the end of the day, we need to establish an accurate relationship between the in-place test results and the concrete strength. We know that the concrete is a composite material. Definitely, that's why we need to work with safety factors. Their behavior, the concrete behavior in situ is quite different from what we have when you are working with samples into the laboratory. So in situ test, the main challenge is just to make it very accurate and precise. So, but in general, we have these three main points. We have the visual inspection, then we can collect some in situ samples, and then we can combine in situ samples with the test conducted into the lab. In relation to visual inspection, some ideas that I just decided to share because it depends on your background, depends on where you are working. Some of you probably have done this in your workplace or not. That's why I will be sharing here with you. In terms of visual inspection, normally we need to identify the cracks, sculling, spalling, the extent of reinforcement corrosion, just visual approach, and then we can map all these problems, right? And at the same time, let's say in situ, we can, I said before, we can compare the concrete characteristics in situ against what we had from the previous experiments working with concrete samples. We have the cores, you have these cores, as you can see, drilled from the structure, and then we can just conduct simple compressive tests. And then what the main purpose, it can be more realistic, right? But we also know every time here you're gonna talk about advantage and disadvantage when you are monitoring concrete structures. For example, that's great because we can have a realistic idea in terms of the concrete behavior in situ, right? But definitely it can be, we need to consider that some repair will be needed later on, right? The positive point, we know this sample is presenting the same thermal history, the same cooling conditions, right? If you are analyzing a slab, for example, we will ensure that our material, our sample, is showing exactly the same, under the same condition in situ, right? So these are some initial ideas. And when we talk about planning, this is the next part we'll be covering here today. Normally we can divide, when planning and conducting in situ inspections, you have these two main groups of tests, right? We have non-destructive test methods. Sorry, I just had a quick look into the chat box, but pardon me, I cannot do both. Maybe I will leave it to the end if you have any questions, okay? For now, let's go back. Testing methods, we can divide in two main groups, right? Destructive, as you can see, we have the traditional compressive tests just to monitor the quality control of concrete in the construction site. And we have some non-destructive tests. This is in the lab, but it's just to clarify. Here we have the sample is totally destructed, and here we have the sample is in a good condition at the end of the test. And when the materials, when you work with the destructive tests, we normally can consider the core drilling and also can consider semi-destructive tests, right? Because core drilling, definitely there will be some damages into the structural element, but we are not destroying the entire slab or the entire beam. So, and non-destructive, definitely it's not going to modify the member's properties, okay, or affect the service of the entire structure. I think this is a clear difference. I truly believe you all are very familiar with these definitions, right? And thinking about evaluation methods, that's the point that I think, in my opinion, this is the main challenge for us. For us, I'm saying engineers, architects, construction management, because there is a variety of new technology coming and there's new methodologies coming, new tests. But even though with the current ones, we have, for example, if you want, the idea is to measure the reinforcement. We have cover meter. If the problem is more about corrosion, we have the most traditional one is the half cell potential, and depends on the type of problem you have in your element, in the structural element. We can conduct both static and dynamic loading tests. We can also assess cracking. We can use ultrasonic testing for some, depends on situation, to identify cracks. And at the end of this session, we will be discussing a bit more in terms of structural health monitoring, how sensors are helping us to monitor the structural capacity in real time. So let's have a look at some of them. Before we go, sorry about that, but for now, what I really want to share with you, we have, every time, we have non-destructive methods, so later on, the structural health monitoring methods, we need to analyze the pros and cons, right? As engineers, we deal with this situation daily basis. And here is a simple example, because these two are the most common tests. We have non-destructive tests, the easy ones that we can, probably you all are familiar with these, ultrasonic pulse velocity and the rebound hammer. But here, the main idea is not to discuss this test, but to call your attention the main points you need to observe. For example, method, if there is some standard available, and majority of them, if you, depends on your country, you have your own standards, but if not, we have international standards we can follow. That's why I'm just giving these two examples, but the point is, we need to observe the description of the method. Each one will present some advantage and some disadvantage, right? And we need to familiarize what we have available, first step, and at the end you can make a final decision which one is most suitable. And you're going to see that more and more we need to combine tests, right? Because, for example, if you have some disadvantage from this specific test, the other one can cover this disadvantage, and vice versa. So that's why knowledge is critical. It's how we can be more capable to make decisions in the future. That's why for today, my main goal is to share with you all the possibilities we have nowadays under this umbrella in terms of monitoring concrete structures. And in relation to this I think at the moment that I was working into this presentation, I retrieved many information from the literature, very, very, very good information. And that's why I think this table is a very interesting one to have as by your side when you need. For example, when we need to compare different types of non-destructive tests, how we can monitor our structs. First idea, this is a very good resource because it's also of information as well, because we have very clear here the parameter measure. For example, we have general idea in terms of the concrete quality, cracks, defects, voids, right? And for these specific parameter, we have this variety of tests available nowadays. And then we need to compare. Depends on the resources available, depends on the cost. Each situation must be analyzed, right, carefully. But the main point, as engineers, we need to know the advantages, limitations, and understand a bit more in terms of each of them, each non-destructive test. In a sequence, we can see now, for example, very fundamental, the fundamental for us is in relation to compressive strength, right? Majority of time we are targeting compressive strength because it's the simple way to understand if the structural condition. And these are some of non-destructive tests, as I could share: rebound hammer, ultrasonic pulse velocity, and there are some ideas when you can use, for example, ultrasonic. It's majority of them, they are portable, but that some of them, for example, rebound hammer, it's more about the surface of concrete, right? And it will be influenced by the surface condition, for example, carbonation, moisture. So we need to understand which problems can be caused at the moment that you are conducting your test, the parameters influencing the quality of your results, definitely the accuracy of your results. And in the same, and following the same idea, sometimes the main target is in relation to the chloride concentration, right? And you have some tests that can be conducted. And the challenging one for us in relation to the corrosion, right? Corrosion rate, corrosion progress. That's why later on we'll be just sharing some of them with you, but we have the half cell potential, and some of them in terms of the qualification, we need skilled personnel to work with these tests, right? Some of them anyone can just conduct straight away. Let's say rebound hammer is super easy, right? But if you have more sophisticated tests, for example, X-ray, or definitely you need more qualified personnel involved. And all of these details must be considered to make a final decision, right? That's why I'm sharing this with you today. And this one, for example, if you are walking with roads and pavements, and I know that some of you are working in the Department of Transport, pavement inspections, we have these very popular ones, this group here, GPR, depends on your country, definitely low cost, but it's portable, it's effective, and then, but there are some limitations in terms of interpretation, right? And we have this one, it's a very simple one. It's a chain track, it's simple, portable, but the main limitation, it's stages, you know? I will never know. Sometimes you can be the next person to conduct this type of test. So the main idea here is to get you ready for this if you need in your professional life. So these are definitely, you're gonna have all this material available for you. That's why I decided to share these tables. As you can see here, you have the reference available if you need more and more details. But another point we normally need to consider in our inspections or later on investigating more details about the structure condition, it's the cover, concrete cover, and location of reinforcement. So we have cover meter, it's a portable, and depends on the slow, depends on the skill of the personnel involved in conducting this type of tests. So lots of pros and cons. Now, this is a different guidance. I think depends on your workplace. If you are working with this, that's why I think the main challenge for us is in relation to the number of measures, number of data we need, and to ensure that these data we can trust into the data you collected. Otherwise, there is a waste of time, right? If you don't have accuracy and precision collecting your data, your analysis will be compromised. This is the main target. So performance measures later on, if are required to conduct or to work with this type of activity in your professional life. Evaluation, how we can evaluate non-destructive methods. We need to have some parameters in mind, right? Some criteria. And that's why I think this is a very good indication in terms of the performance measures we can have in mind. Accuracy, precision, repeatability, ease of collection data, analysis, interpretation, speed, because these two criteria, they work together, right? Speed and cost, time and money. So what I'm trying to say here is there's numerous technologies available in terms of the methodologies, in terms of new equipment available into the market. But we need to have some guidance at the moment that we need to define what type of non-destructive test you'll be conducting. And I think this is a good start. If you think about these 5 criteria, accuracy, precision, if it's easy or if it's very, very sophisticated, nobody can conduct this in a proper way, it's a waste of time, right? You need to invest more money and train people to work with this equipment. And speed, time, and money. And that's why, in terms of deterioration types, that's why I will be just sharing with you when you apply these 5 criteria at the moment that you need to identify delamination, corrosion, cracking, and general concrete deterioration. This is the point we'll be having a look, and that's why I also think this is a very good source of information. That's why I'm sharing here with you. We discuss it, right? For example, performance measure in terms of accuracy. In terms of delamination, we have some determination of depth of delamination, how in terms of corrosion, detection of active corrosion, cracking determination of the crack depth and width, precision. If you look into each type of deterioration, you have some guidance to follow. Precision, repeatability, and the measurement, and what type of estimation we are doing here. We need to have accurate measurement in terms of the depth, how it's possible to detect delamination, right? And the severity of delamination. It seems simple, but sometimes it's not that easy to identify pretty much the severity of the deterioration we are analyzing. So precision is very important. And for example, in relation to corrosion, the severity of active corrosion, right? Something that must have in mind. And easy to use, speed, cost, all these guidance here, this definition can be applied for any type of deterioration, right? So let's move to the next slide. And here I just share at least one of each in relation to the type of deterioration. You know, we have some micro cracking sometimes in our structural elements regarding several problems, several cause, alkali silica reaction, entringite formation, plastic shrinkage, freezing, thaw cycles can start in a micro point of view, but cracks over time, cracks progress and grow, and cracking propagation, we know, it's one of the main challenges we face as structural engineers. And here is just to share with you the laminations on this type of test, the impact echo impact. We can see here the main idea is just to analyze when you have good condition, no delamination. When you have, for this one, is still in a fair condition regarding the wave propagation, right? It's possible to understand. It depends on the depth of the reflector. You can obtain the return frequency. And when you compare different situations, you can just rank it into fair or very serious, you know, this one here, and poor, or it's always good to have a reference, right? Just to, then you can compare the other ones. You have the struct here, right? The surface, the deck, you have the struct, and then you can see the wave propagation, and then you can see the return, and you can just evaluate these different conditions, right? So it's just an example. As you know, I'm trying to share general information with you to familiarize the ones who never worked with these type of tests. And now it's your turn. Now I really want you to answer this question. Let's see, engineers, architects, and construction professionals, just type into the chat box just for us to have an idea. As you know, our main problem working with reinforced concrete, as you can see here, concrete is a protective layer, right? This is common sense. But depending on some problems, we can, this protective layer can disappear, right? Depending on concrete pH. So I want you to just type. I can see some of you, Richard. I can see Matt. I can see Jason. It's a pop quiz, just to warm up your, okay? Because the main idea here is just to, later on we'll be discussing how we can measure the pH. Nowadays we have sensors, so pretty much you all are doing a great job. Well done. High distinction for everyone. Definitely this is the main advantage to work with these two materials together, concrete and steel, you know. I think this is the best combination we have when we are studying engineering materials. And definitely, this is the main point. This type of information, you know, it's very relevant in our area. So thank you all. That's great. You all passed high distinction. And just how we can measure corrosion. We did some, I'm just going to share with you some other tests. We have the half cell potential, or HCP, and we can identify via this test the active corrosion. And sometimes you have these conducting those reinforced concrete or pre-stressed concrete structures. And another very popular one is the GPM. This covers the same. Sometimes it's the half cell potential. Sometimes the measurement can be influenced by if the concrete is wet, or if you, let's say, if you're working with concrete, polymer modified concrete, depends on the concrete component, can influence the final result. And nowadays, GPM is the one that can be used as well. And this depends on the operation of the GPM. You can just avoid the problems in relation to the concrete humidity, or if it's dense. And so when the access, here we need oxygen, right, to have the good result. So for now, is just to share some ideas in relation to what we have available nowadays. And cracking, we can also have the resistivity. To the main idea is just to identify the moisture detection. This can be linked to the presence of cracks, because cracks for us, it's straight away, it's a very important point in relation to later on how the corrosion rate will increase as cracking grows. Definitely, if we're working with reinforced concrete, the corrosion rate will increase as well. So the other ones, we have the infrared demography, this to detect the subsurface defects, right? And these types of anomalies, we have the voids, we have the materials change. These can be detected, the materials properties can be detected. Types of properties, density, thermoconductivity, specific heat capacity can be, and this is can be detected using the infrared demography. And this is a good one, this example we have here. It's interesting, the chain dragging, as you can see, it's a very simple test, no sophistication. If you compare the demography with chain, this is relying into the sound, right? You need to have a very skilled labor here, because depends a lot on the sound of when you are conducting this type of test. So here is more about sharing with you the type of non-destructive tests. And you also have, if you're working with pavements, this is one of the most popular one nowadays, right? The GPR, right? We can produce the contour maps on the surface. So GPR, we can assess bridge decks, pavements, tunnels. So there are so many applications that can be where you can apply these type of tests. But I just need to go through this part now, just briefly, right? In terms of statistical consideration, as I said before, my main goal is to share with you some guidance in relation to ASTM, American Society Testing Material. Normally we can, in terms of sampling, if you think about precision, if you think about accuracy, sampling is critical, right? So preliminary investigation, when in this case, the information that we have conditions similar, same throughout the structure, right? This is one criteria that you can use. And the other one, when you have the preliminary investigation, so the conditions are not similar, right? And then the structure is divided into portions. So we have what the main purpose now, just to guide where you can find information later on when you need. And very important to consider the sampling, right? How you're going to collect your data. And in relation to American Concrete Institute, this reference you have here, The evaluation when you use these, the non-destructive tests, we have some requirements to follow. This is the point, right? If the cost, if it's an intrusive testing program, the area, the volume must provide a large amount reliable data. You must be aware and identify areas that are very difficult to inspect. So you can sometimes need to use majority of the time, honestly, more than one type of method. And include, if it's reproducible, recover data. So in the future surveys, you can use some previous information with confidence. So some requirements you can have in mind. And in terms of data, following the recommendations, American Concrete Institute recommendations, points tested, easily identified, test results. More and more, we need to be able to analyze the data using statistics, statistical considerations, yes. And also, we can think about the reproducibility of this type of test, statistical confidence. So, and definitely each standard depends on the type of test. You provide some ideas in terms of statistical aspects, in terms of standard deviation. For example, this is the common sense, right? You can follow this just to identify if the repeatability with some percentage to have in mind, right? And see if it's acceptable or not. And also planning and identify which type of tests we can conduct. This is the main challenge, right? First step, identify non-destructive tests. Some of them can be used when we only have one side of the elements is accessible, deep foundations. So the tests that we are now exposed to, the variety of tests available, they must be suitable for all these situations, difficult access. And just like a mini case study, but it's not just in general idea. When you have a bridge inspections and monitoring, I will just kind of share some ideas in terms of inspection. Normally, inspections and monitoring, I just take an example of a bridge, but it applies for, we have general serviceability, maintenance, identify the maintenance needed, the possible defects, distress, and we all need to know the conditions, load capacity, in-service performance. So that's why we can have different levels of inspection. We have level 1, just visual inspection. Level 2, when you can conduct and you can use some condition rating, and the detailing, engineer inspection and investigation. So in a sequence, I'm just gonna go briefly via the condition state. Normally we can consider condition state 1, here an example of the concrete substructures when you have some water stain inside, superficial water stain, nothing very, very bad, if you can say like this, but the cracking is still widely spaced and not very frequent. But then when you progress, we can progress to condition state 2, and you can see there are some issues, still some deteriorations that the crack shows. Now, if you compare with condition 1, condition 2, it's more severe, right? And so on. Condition number 3, it's when you can identify easily. You can identify the spalling, some obstruction of movement, and several cracks, macro cracks we can visualize, right? Easily. And this is the worst case scenario when you have the severe impact, you have damage, right? Or fire some, it's how it just depends on the level of severity. We can have different conditions, right? This is the point. And now it's your turn again. We are almost at the end of the session. So now we're going to talk briefly in terms of structural health monitoring. And can you just type in the chat box? I think it's the simple way. Can you type some benefits? If you are familiar with structural health monitoring, can you just type some benefits of structural health monitoring? And at the end, definitely, I will look at the chat box. I know that some of you have some doubts in relation to the previous slides. I will try to answer later on. So, valuation, easy detection, some other benefits in relation to what the main problem. Real-time monitoring, CLEs, yes, that's great. And we need to avoid catastrophic failures, right? We have these automated monitoring systems nowadays. We have these new technologies, so many different equipment, sensors, cutting edge information, right? Mechanical failure, definitely, Stuart. So this is the main point to share. It's just why we're gonna complete this session, just having another idea in terms of structural health monitoring in civil engineering, right? It can guide us in terms of the maintenance and management, right? The level of service in a safe and cost-effective manner. So normally we can follow these different levels in terms of damage, right? I think you can just follow me this way. Level 1, damage detection. The monitoring, you're going to give an indication of the damage. Then we just not only need to detect, but localization is critical. We need to understand, we need to identify the position of damage, classification, type of damage, assessment, the extent of damage. So when you are working with health monitoring, yes, yes, it's for human, I truly believe, yes. And prognosis, safety of the structure. This is the main challenge structural engineers face, in my opinion, is how it's possible to estimate remaining useful life. That's why I can imagine the level of accuracy and precision of these monitoring systems. So here it is just to summarize. For some of you, if it's a new topic, that's why I just summarize it here in one slide. You can straight away identify the structural health monitoring, the main idea. We have the sensors, data acquisition, but not only this. The challenge is data transmission, processing, management, health evaluation until you have your final, you need to make some final decisions, right? And how it can be done in real life. Normally the systems we can divide, as you can see here. We can divide in global monitoring and local monitoring. And in terms of global monitoring, we have some physical parameters. What type of measurements we can obtain from these tests? We can have deformations and displacements, frequency variations, dynamic flexibility. In terms of local monitoring, the main difference between global, we just need to have the entirety, just have a better idea, a whole idea in terms of the parts of the structure, right? And normally we can use accelerometers when you are, the main idea is just to obtain information in terms of the dynamic response, when the structures naturally, can you imagine, breathes, they are subject to the ambient vibration, and local monitoring It's more specific, as the name says, as you can obtain information in relation to cracking or fatigue, so we can collect some local material and geometric properties. So there are, now I said before, in the literature, we can go through this. For example, this simple example I will be sharing. We discussed pH later on. Now I know your knowledge in this area. So we can have some fiber optic sensors. It is what we have in terms of different research groups working with this area here. Some pH sensitive membrane, we can do this automatically. Or in the old scenario, we can just spray phenolphthalein, for example. So we can have these two alternatives, or you can go via the old times, and it's just very efficient the same way. But if you have this automatically acquired, it's more beneficial. So it depends on the resource, depends what you have available, depends on each project, right? But here is just to share the main possibilities. And in terms of sensors, we have these two main groups nowadays in terms of sensors. Contact sensors, we have, I said before, accelerometer, LVDT, strain gauge, piezoelectric sensor, ultrasonic wave sensor. These, what's the traditional ones? They are directly attached to the structure. But nowadays, we have the wireless. And wireless, what's the main challenge when you work with wireless? It's data transmission, right? So all these informations are important for us to familiarize with this topic and just to have an idea what in your situation, your workplace, how we can apply this information daily basis when you need, right? And currently, if you have a look later on, it's about, depends on you, it's depends on your curiosity. Nowadays, we have so many different alternatives, right? We need to advance and develop alternative methods. What we are aiming to as engineers, more efficient sensing systems, right? That's why we call it next generation sensing technology for structural health monitoring. So we can acquire, analyze, and the validation of data. Nowadays, you have these alternatives. You can work with smartphones, drones, camera, robotic sensors, right? This is all available. So, but I said before, depend on your specific situation. But for now, you need to know what is available, right? This is the main purpose. And that's why I think it's a good idea every time that you need to explore more about a specific topic. That's why today I'm trying to summarize as much as I can. Definitely we need to explore or to have available into the literature. And that's why I retrieved this information from a journal, a paper. And here, as you can see, for example, camera. There are so many different types of camera available with some techniques, different mathematical techniques, and the main problems in relation to each of them. It is an example of camera. The other ones I have until the end is in relation to drones. This is only one part of material I retrieved just to summarize for you. There are so many research groups working into this area, right? But definitely what you need to have in mind, if you have the drone, you need to have the model and the type of application, right? And the other one, smartphones, iPhones, Android, we can see each of them, some issues that can be addressed, the problems that they are facing nowadays, right? When they are working with this new generation of these new technologies. So this is the point. When you start working with a new technology, please familiarize yourself what people are doing this globally, right? And I just trying to finalize this session. I know that's a lot of content that we have to share. I can imagine the amount of doubts, but the main idea, I just briefly have a conclusion in terms of the non-destructive methods. More and more, as you can see here, this is it's just to illustrate when you have more than one method combined. Let's say rebound gamma, ultrasonic pulse velocity, you can have a more accurate estimation in relation to compressive strength, if this is the case this is the problem that you are facing. So more and more in non-destructive tests, when the engineers work with this technology, not only a single method can be used. Now it's clear the amount of equipment available. Definitely more than one can be combined, and you can increase accuracy, you can increase precision. And in relation to the next generation, that's why you leave this part with you. Each of them, you need to understand the benefits and the pros and cons. And here is a summary. It's just a summary for you. Later on, in your own time, you're going to be able to digest all this information, and definitely we are here to help. We are here to solve your doubts as much as we can from the best of our knowledge. And here I have the reference list for you. You're going to receive this material, as Riley mentioned at the very beginning. And now I just need to say thank you all in different countries. It's a great pleasure to have all you here today, right? And share this topic. I think it's a fascinating topic from my humble opinion. I'm not sure if I'm working with this in your professional life, but definitely one day you're gonna use it. Deterioration is our common area. So thank you all for coming. Thank you, Riley. It's over to you.
Thank you, Dr. Anna. Very much appreciated for that presentation. As you can see from the chat box, everyone is very appreciative of the session today. So thank you very much for that. I would just like to mention to everyone, if you would like to attend one of our next technical topic webinars, just visit our events page on our website. We have an electrical engineering topic coming up on the 23rd of September. If you're interested in that one, so that one will be the feasibility of converting overhead transmission lines to underground. And then we also have a gas turbines webinar. So yeah, the link is there, or you can visit our website and go to the events page. And as everyone's been requesting, there is a certificate of attendance that's going to be provided to attendees for this session. You'll just need to fill out the form, the short form and survey on that link, or if you have your smartphone there, you scan the QR code, and that will take you to the form. Once you've completed that form, we will send out your certificate to you, hopefully within the next 4 business days. So if you would like a certificate of attendance, please use that link on the screen. I'm also going to post the link in the chat box as well. So I'll just leave that up there for a little while, and I've just posted the link in the chat box. So please go ahead and do that if you would like to. And I'll also start the session, start the Q&A session. Sorry, someone's just asked for the upcoming webinars, so I'll also post the link to the events page, which contains all of our upcoming and past webinars. Okay. So if anyone has any questions for Dr. Anna or I before we conclude this session, please post your question in the chat box and we'll try and answer your question while we're live. Anna, I think Dean has a question for you. He says, how can we use structural health monitoring as a way to bargain for a lower price in homes with large amounts of structural deterioration?
Yeah, I truly believe the main idea, I think it's good to have if you can conduct an in-situ inspection and map all the problems, and definitely you need a structural engineers just to identify the severity of the damage, and then you can use this in your own benefit. If you're working as a structural engineer, definitely it can be done.
Thanks, Anna. Shadrach also has a question just regarding how lightning strikes affect concrete structures. Maybe if you could comment on that.
Depends, that again depends on the severity of the damage. I can imagine the lightning strike can just start with some, depends on the severity, I said, can start with some cracks or spalling or different types of degradation, right? It's like a shock, right? Something that you are not expecting. And definitely that can just lead to the failure, to the collapse of the entire element, depends on the severity of the shock.
Yep. Thanks, Anna. Filani, so for this session, we do record this session. So if we will send you the PDF slides and the link to the video recording of this webinar to you and everyone else registered for this webinar within the next 2 business days. So just keep an eye out on your emails or your junk email folder, and you should receive that within the next 2 business days. Kamaru, I think you're asking if you can become a member of EIT. You might want to, if you're looking for employment opportunities, feel free to send us an email using the email address there. Or if you are wanting to study one of our courses, you can get in contact with one of our course advisors through our website or give us a call. Dean has another question for you, Anna. He says, can we use these testing methods to test the properties and integrity of other materials other than concrete?
Sorry, my microphone. Yes, we can apply nondestructive tests in timber, steel, any other type of material. And the same for the structural health monitoring. There are not only civil engineering application, but other engineering areas application as well. But in terms of materials, definitely you can work with non-destructive tests, not only with concrete, but steel, timber, these are the most popular ones. Yeah, in terms of structural analysis, yes, you can do this.
Thank you, Anna. Abigail, so everyone that registers for this webinar, so in order for you to have joined the session today, you would have registered through our website and Eventbrite. So you will receive the PDF slides and the video recording to your email within the next 2 business days. However, if you are wanting to receive a certificate of attendance, which we provide for these technical webinars, you can access the link that I've just posted in the chat box, and we'll send that to you hopefully within the next 4 business days. Edison has a question, Anna. If we have old concrete structures, how can we prevent corrosion of steel bars, or is there any way to prevent corrosion?
Definitely, this is the 1 million question, Edson. So the main idea depends on the level of the corrosion, the progression of corrosion. It's not possible to go back. So that's why the most important thing when you are working with reinforced concrete is in relation to the concrete mix design. When you have a more efficient concrete mix working with pozzolanic materials, different cementitious materials, we can ensure that concrete is denser. The main problem in relation to corrosion is concrete porosity and permeability. It's how we have the carbonation, we have the ingress of salt, carbon dioxide, and it starts the corrosion process because the pH decreases, So, but this is another area we can, for example, if it depends on the level of severity, there's some alternatives in terms of repair or reinforcement, right? As structural engineers, we can reevaluate the structural condition and then make a final decision. If it's only a repair or for some straightening, we need to increase the entire structure capacity.
Thanks, Anna. We have another question from Charles, and he's asked if I've experienced in my structural inspections problems occurring in the construction joints. Is the construction joint really that big of an effect, or was it just the construction methodology?
Charles, in my opinion, is a combination because, the construction methodology sometimes you have, in terms of the design, it's not a good design if you just, for example, lack of a plan in terms of the drainage system can also implicate into these problems that normally we face in joints, So I think it's we have the natural deterioration of material, but definitely, in my opinion, the lack of drainage system sometimes is one of the main causes of the problems we can see in joints over time. Yeah.
Thank you. Dennis has asked, what is the best method in evaluating the health of the overhead concrete poles?
As we could see before, there are a variety of methods. Depends on the resources available in terms of the cost, time, what we have in your company, what you are interested in investing into this. But yeah, in terms of the concrete poles, depends on the type of situation we are facing. It's more about the concrete resistance, the concrete strength evaluation, what type of deterioration.
Kamaru has asked if painting a reinforcement with epoxy paints in the areas where corrosion level is high, would that be beneficial?
You can try to stabilize the corrosion progress, but what is done is done. There's not recover, that's not self-healing, I can say. But yeah, definitely you can try to make it stable, right? To not progress. Let's say, if it's an initial state, probably it can be one alternative, but depends on the level. That's why you need to measure the diameter of the reinforcement bar and reevaluate the structural condition.
Thank you, Dr. Anna. I believe that is about all we have time for today.
Yeah.
So thank you very much.
As well, I have class now. But definitely just send a nice email and keep in touch. And I'm happy.
Absolutely.
I'm more than happy to provide some feedback, more detailed feedback and response.
Yeah, so thank you everyone who is still in the session. Thank you for joining today's webinar. We hope to see you next time. And yeah, please contact us. Send me an email to that webinars at eit.edu.au if you would like to contact myself or Anna. And yeah, thanks for your time. We appreciate you joining today. Okay, thanks, Anna.
Thank you all for coming. Keep in touch. Bye-bye. Take care, everyone.